Hello, everyone. As we gather, feel free to go to our presentation link, and I'm going to share this with you in the chat. But I love that you're here, and I'm excited for our session. And you should also be able to see my shared screen. Nice. Wonderful. I appreciate it. Helps me understand how to teach you best if I understand what you teach. So wonderful. Adaptive PE and substitute teacher. This is perfect. This is my classes for you today. Welcome, everyone. Take a moment, pull up the presentation. I put the link in the comments, and it's there as a bit.ly link for you. And if you can tell me, what do you teach? Go ahead, put it in the comments. What do you teach? And if you don't teach, what do you do? Let us know in the comments. That helps me feel like I'm in class in this remote world. I hope your conference has been going well for you. Nice. Excellent. I am thrilled to be able to speak to so many special ed teachers, to substitute teachers. This is my perfect audience, so I'm so excited to share with you today. But welcome, everyone. Nice. Work skills in the Workability 1 program. Very nice. So while we have a few minutes, go ahead, pull up the presentation. That's yours to copy and keep if it helps, and the links to all the lesson plans that I'm going to send off with you. Just have a few more minutes. Nice, and younger students too. Wonderful. TK through 5th. Very nice. Welcome. Glad to have you. So we have the whole span from transitional kindergarten all the way up to workforce skills. That's an exciting group to have. See, this is where I miss the in-person part where we actually get to chat before a session. But I do appreciate we get to keep doing this even though we're remote. Yes, the description looked slightly different. That's an excellent question. Is this presentation different than the one we did at 10:30? I kind of morphed it into the same. It is going to be pretty much the same, although you get a second look at it. I decided to do them both sort of hands-on because otherwise it's really boring. That's no fun at all. And I'm trying to keep an eye on comments even when I do speak. I didn't talk about Google Colab. Google Colab is my new love. It turned out that in a 45-minute session, you can't talk about too much more. But Google Colab, I think, might be my new favorite tool for also just teaching kids to code, because there it is, a Google Doc. You don't have to have a program. And again, it's these real world tools that I think kids need, right? They're less impressed with learning Scratch than they are when they can do something that adults are using. So, oh, and it's Ruby. Hello, Ruby. Yeah. I'm really interested in how do we get these kids interested in data science, in artificial intelligence, in all of this. And so this works for that. All right, one more minute before we begin. We're on a very tight time frame, so there's no running over here. So do take a moment. You can go to bit.ly/MacGyver Teach, and you will find this presentation. I also put it at the very top of our comments. And so you can always find it, follow along there, and it has links to everything. The other piece that we will be pulling up, and it links to this, but it is ninjapandas.com, and you will see in the sidebar, look for the NetLogo lesson. And that is also where you'll find everything is either in my presentation or all your lesson and student plans are right there. And with that, it is 2:30. I welcome you all. You're nearing the end of an amazing day of a conference. And my name is Claire Bachta, and I am here to teach you computer science MacGyver style. Now, what is she thinking? You might wonder, because we have 25 of you here today. Welcome. I am a CTE computer science teacher. I have been teaching kids grade kindergarten all the way up to college, actually, for the last 10 years, how to code, how to create, how to invent, and how to creatively think and learn this material. And so we started today. I came up with this idea because they said, well, what do you want to teach? And I was like, well, what have I really gotten pretty good at as a teacher in a pandemic? And I would say computer science MacGyver style. So let's see. Oh, there we go. Now, in my memories, MacGyver could do anything. I was very impressed with MacGyver as a kid. I feel like I modeled a lot of what I learned and aspired and still do through him. I'm a maker. I'm a coder. I'm an inventor. I do all sorts of stuff. And I like to make something out of nothing. But what I really remember MacGyver for was you could give him a paperclip and a rubber band, and he could stave off disaster, and he could do it under pressure with tight deadlines and dangerous circumstances. And I actually feel like that's exactly what we do as teachers every day in this pandemic. So I want to give a moment and a round of applause for all of you, because you guys are already teaching MacGyver style. And the fact that you wanted to show up and introduce computer science too, I think is just awesome. So welcome. Thank you very much for coming today. Now, as I sat down to prepare this slide deck, I thought, there's a problem in my concept, is that MacGyver wouldn't tell you what to teach. And here we are, we've already had to work under MacGyver conditions with this pandemic. And I realized MacGyver wouldn't tell you how to teach. He wouldn't tell you this is what you should teach, but he would enlist you in a very important mission. And this is the mission. And MacGyver, I would assume, wants to expose every student to computer and data science. This is my mission, my MacGyver mission. And to do this, you're going to have to find your own paperclip because we're remote. But we're going to throw you an emergency subplan. Because when I sat down and I thought, well, what do we do with already stressed special ed teachers, all these people that are already doing so much, how do we ask them to do more? And that's not fair. So this is the plan. Every single one of us, I would gather a guess, is going to get called out because we might get sick. We have something with our kids. Maybe we get a day off. Maybe we go to some PD. Whatever the case is, with your paperclip and an emergency subplan, the goal is to expose every kid to computer and data science. Now, why, right? Why? The why is very important. The why for us as teachers is important. And the why to tell our students is very important. And this is my why. I teach high school right now. And what I have noticed, what I've observed in 2 years of teaching CTE high-risk computer science students, is that by the time they walk into the class on my very first day, they have already decided if computers are right for them. Now, the other thing that I've learned by being a CTE teacher in brand new programs where kids are just being mass enrolled is that the students who excel in this are not easily identifiable. And yeah, we may all have a student who we could say, oh yeah, I think that person would do well in a coding class. And those ones that we assume will do well actually probably will. But it is those other ones. It is the other students that we do not assume who will do well, that you have in your classrooms, that you have from age TK through workforce right now, that I want to get to, right? And I can tell you this, I've been teaching this for 10 years, and most of my best students, very qualitative, I have no quantitative data here, although I wish I had collected it. Most of my best students of 10 years of teaching youth how to code and create are on IEP plans. Right? So I do work with students that are not expected to do well, but excel. And so that is why I want to get them a little bit early. And I'm thrilled that I have elementary teachers here because what we can do is get them interacting and talking about and playing with giant data models and artificial intelligence. We can do this, right? Like we can do this. We just need to expose them. Now, I'm not asking that you're a computer science teacher. I want all of them to touch it and play with it. And so it's not so pushed away. Not coding is not an identity by the time they get to my class. All right. So in our class today, and this is what your class subplan would look like, we're going to talk about what is an algorithm? Why NetLogo? We're going to explore some models on our own, and then we're gonna take 5 minutes, very quick abbreviated version, and then we're going to come back and we're going to share our favorite models on a class Jamboard, and mimicking what you would do in person. And then we're going to I'm going to show you where I stash these lesson plans and other things you can have. And at the end, I will have time for questions, but also if you pop up in questions, I'm looking at it in the chat too. So let's get started. Why? Why is very important. And why is very important for these students too? Like, why should I care? Now, this is where it comes from. I had this aha moment. I did not learn that there was an algorithm for how birds fly in a V, or how fish swim in a school, how ants walk in a line, how bees create hexagons. I did not understand that there were algorithms behind all of these things. I did not learn that in a math or science class. I learned it in an animation class. And that blew me away, because here I was trying to be an artist and learned that these algorithms, this math that I had fought so hard to avoid, was actually staring me in the face and is everywhere. That is why. Right? And an algorithm is a specific set of instructions. That's all it is, a specific set of instructions. And so when we talk about NetLogo, it is algorithms for all sorts of things in everyday life. And I believe that there is something that will interest everyone on NetLogo. And I've done this assignment across a couple schools, across about 150 kids, and I didn't find a single student who couldn't find something that interested them. Now, what is NetLogo? NetLogo is a real world data modeling tool. It comes out of Northwestern University, and scientists and social scientists and mathematicians, all sorts of people, create visual data models that you can play with, and you can change the variables in the model and see how it affects the whole. And so in a sense, it is a collection of algorithms, a specific set of instructions for how fish swim, or ants find their way, or honeycomb is made. And so NetLogo, I think, is essential because it takes science and math and sociology off the page and out of theory and puts it on the page, very much like a video game that our students can play with. Now, I also believe that it's a great place to explore, to play, and to learn, and that there are algorithms everywhere. This is just a great way to introduce that concept. Now, in my lesson plan, I have videos that do all this speaking for me. So this gets there. And so the first thing I tell my students is beware, NetLogo is not at netlogo.com. So it is the first thing you find if you Google, but I'm actually going to take you there from this presentation. I'm going to take you here. Here is NetLogo. And it's important to know that there are two kinds. There's this desktop version, which, you know, if you're really going to make models in NetLogo, that's the way to go. But we're exploring, this is MacGyver style. We're not trying to get anything approved by IT. We're not trying to do any of that. So we are going to go here on the right to the Go to NetLogo web. So many people do not know that there's a web version. And every time you go to this web version, it actually generates a different model that we're looking at. So this drop down up at the top, these are all the models that are in this online version. So we can see wolf, sheep, inheritance, plant growth, polymer dynamics, sand piles. We can look at sample models in physics. If you look close enough, you're going to find video games. Just FYI, Pac-Man is not working today, but Tetris is in there. I have found everything from rebellion to riots to viruses to fireworks to fractals. So anything from art to video games to math to science. There's even neural networks, right? There's even artificial intelligence in here. And it doesn't look like much, right? It doesn't look like much, but it is a lot. So as you explore, the couple things I want to show you. This top part, right? This is the drop down, and you can search by topic, right? Like, so if I want to look up, I have a favorite ant game. Well, this isn't even it, but this one's fun too. And when I look at it, And it's hard to tell what this is about, right? Like, what is this about? I don't really know what an ant line is, but I want you to look at these purple tabs at the bottom of the screen down the center. Now, the bottom one is the model info. And when I scroll up, every model has this, and it tells you about it. So what it tells us, it says this project models the behavior of ants following a leader towards a food source. The leader ant moves forward along a random path, and after a small delay, the second ant in the line follows the leader by, it just smooths out the curve somehow. Ants are amazing. So it'll tell you how to use it. We start by saying setup. We can play with the number of ants. We can play with and then things to notice, things to try. So it really scaffolds this learning for your students. So let's go up here. Then that's the model info. This NetLogo code, this is actually the algorithm. This is actually the code that creates what you're going to see up here. And Command Center is actually like command line. If you could, if you just go in there, you can actually type things, but we're not going to mess with that just yet, in a little bit. So let's try it. Let's see what we were told. We were told to hit setup, and then we were told to hit go. And so here you see my beginning ant, and you can change the delay. You can change the angle of the leader. If I want to reset it up, I'd stop go, I'd hit setup again. Right? So you begin to see somehow how they smooth the curve, right? Ants are magical. And so we get to play with these individual pieces. Now, when we're talking about code, these are all variables. The number of ants is a variable. Leader's angle, wiggle angle is a variable. The delay of the start is a variable. The number of ants released is a variable. And what we get to do as users in this situation is play with those variables. So all in just one page, we get to see what code looks like. We get to learn about what we're supposed to be looking for with information to scaffold our exploration, and we get to play with it. We get to start it, stop it, and keep trying it. So that's just a little bit, and it is a whirlwind. Don't do it this fast with your students. But what I want you to do now is this. I want you to spend 5 minutes to explore. Now, we will not judge you on which one you pick to explore, because 5 minutes is not accurate enough time to do a lot. But we're going to do 5 minutes. So if it is 2:43, I want to see you back at 2:50, a minute before 2:50. And what we're going to do when we return, I'm going to come back to our presentation. I'm going to go down a page, and oops, I want us to share. So there's a class Jamboard that I created. And if you haven't used a Jamboard, it's pretty simple. There's controls down the left-hand side. Pick this sticky note. You can type in it. I explored ant lines. And you would tell more because you wouldn't be waiting. Okay, so you just hit that. It comes here. You would give me more of what you explored. But here is the site. I'm going to put this link for you to have in the chat. And in 5 minutes, I look forward to seeing you back. That's the Jamboard. So just as a reminder, we are going to explore NetLogo. Any of these that you want to look at, you want to play with. And what I want to do is bring those all back so we can look at the variety and interests of the people on this call. So I'll see you soon. You can always ask questions during this time. I'll be watching the comments. Yes, I will repost that. Nice. Sweet. All right. Okay. So that's a very good question. I don't know where to start. That happens because they're not all the same. So I'm going to look for Tetris like you are. Here's Tetris. Now I could look under model info. They're not always as good, but what I can tell you is because I've played the Tetris, what you're going to do, Tetris, you're going to start with new and then hit play. And then these are actually, you have letters you can control, J, K, L, and drop. Or you can use these controls here. Now, you can also change the speed of any of your things by changing your model speed up high. I hope that helps, Claudia. And I'm going to peek at Autumn. Now, did you see how fast that went too? Not to talk over you guys as you go, but you can actually control the speed of your model. How many ticks are going on by this scroller at the top? And that's an excellent point somebody put up there. They were here last session, and this time they changed and observed what happened over a period of time. And I feel like the first time we play, I tend to, and this is what my students do, maybe that's why we have so much in common. I tend to max out my sliders and I play around and I look for drastic stuff. And then the second time you come back, you think, I wonder what's going to happen over a period of 2 weeks. You're more refined with your observations. So if you were to use this as a sub-plan, I would say it could be repeatable too, because kids are going to go to different places, do different things. Nice. Excellent feedback. Nice. Traffic. I mean, where else can you talk to your students about fire, rebellion, viruses, traffic, fall, fractals? It's just this amazing range. Do you guys want a few more minutes, or do you feel like you had Signal if you want a few minutes in the notes. Otherwise, I might. Yeah. Now, this is interesting as we talk about how to do this, right? You can do it forever. I will totally give you a few more minutes. I love hearing how you guys have such a wide range of ages. And so I love feedback on, I think, well, my daughter, she's 5. When I prepare this stuff, she's up there playing with stuff. Um, I find that it is really fun to kind of play and explore. And I've been working on this stuff for months, and I still come back and find models I haven't found. I still find interests. And even as an adult, and one of the things I want you to do is I want you to get connections made with your students. So if you're studying how the leaves fall, like my daughter came back from TK the other day, she's studying how leaves fall. I could take her here and say, hey, you want to play this, you want to play with this about how leaves fall, right? And so, and I feel like my students naturally make those connections. And so that's really what we're going here. And so what you've done is you've been playing with massive complex systems and data sets. Some of you may have gone into artificial intelligence, but you're in a real world tool. Don't be fooled by the simple graphics, right? It is a real world tool for exploration. And the first time I did this with my students, I just had them write it in a worksheet. And I realized I learned so much about my students by seeing what they looked at, right? And so that's why I really feel like if you're going to do this in the classroom, if you're remote, do it as a Jamboard or however you like to share. But if you are in person, I would have them make posters about it. I would really like turn it into like sort of a full-on fusion, make posters on the walls. What did you explore? What pieces did you play with that affected the whole? You can really play with that cause and effect. So what I'm going to do right now, I'm going to take us back because there's a few things else I want to do, right? So here we are, we explored. Now, that is one lesson. And I believe the exploration, what we just did, I believe that all ages, in all forms, everyone can do that in some way, right? Now, I didn't have 100% success teaching all students in NetLogo how to code, but I only want everyone to have at least one successful line of code, because if not, coding is an identity, right? As like, I have never coded, I don't do that. Once they do it, once we break the identity that they don't do that and they've actually done it, then there's not that same negative association. And so we're going to do a little piece of code. I'm going to show you, even though this isn't what it's made for. They didn't make NetLogo to teach people how to code right now, but it's really good at it because it's this very clear-cut environment. It's very gentle with its syntax. So I'm going to show you right now. All right, so I'm going to come here. So I'm just going to take you to our lesson page, right? I'm going to take you to the lesson page. Here it is. This is on the Ninja Panda site. If you can't remember anything out of this and you need to ever track it down, I promise the Ninja Panda site will house this for perpetuity. And when you come, you'll do a search for NetLogo. And so you're either a student or an educator. If you are the educator, I have a lot of these slides right here. And I have lesson overviews, I have worksheets, and I have tips, right? But you're a student today. So I'm going to take you back. We're going to go to the student side. So like I talked about, here's an introduction to code, sort of why I was like, I love this. You can watch that video there. The whole exploration is here on this side, where here's a worksheet, here's the link to NetLogo, here's a video that tells you how to explore, just like I broke it down. But what I want to do is I want to take you to this side. I want to take you to create. And the create part is this. It has a series of videos on how to code. It also has a worksheet. It has some references, like there is a color chart for you to use. There is a shapes chart. And there's a code sheet, which literally breaks down like, here's some code snippets to try. Now, as a teacher, I especially, if you could, if everything is perfect in the world and you're not totally MacGyver styling this, And especially if your students have a hard time going from one screen to another, I would print this stuff so they could have it and physically write it out. But it's MacGyver style, so who knows what you have. But you have all these resources here, a worksheet for students to screenshot what they do and copy their code. But what I've done right here is I've created a blank model for NetLogo that's right here. So they don't have to go anywhere else. They don't have to do anything. And you notice it's a blank model. It's exactly what you had. Now, when we go to the code, this is what you see. So I'm going to teach you a little bit. Before I said command center was sort of like command line. And so this is where I can teach you to do your one line of code. So here is how it goes. NetLogo is a language of patches and turtles. And patches are the ground, like a patch of grass. And turtles are the things that crawl on them. And they could be any object. So we're going to, and all computer code is learning how to talk to your computer or your device in a language that it understands. Now, I like NetLogo because it's an easy language. It's not too picky. It doesn't require a lot of punctuation or spacing. And so this is command line, one line at a time. I can type to it here. So I'm going to do this. It's a polite language. So I'm going to say ask patches. That's the background. Now, I want you to look very closely. Both ask and patches are in a color, right? Only reserved words in NetLogo are in black. So if you were to, like for instance, a reserved word would be setup, right? Because it has a specific role in this would be setup and go, right? But most everything you're typing in code is going to have a color. So for instance, if I asked a patch, asked patches, but I misspelled it, you see that it's black. So color is your friend to kind of look at this. So we're going to ask it politely. Ask patches, ask turtles, right? You have to ask what you want first, ask patches. And then things in NetLogo, the commands like to be in square brackets. And the square bracket is just to the right of the letter P on your keyboard. Oh, but not with the cap, not with the shift. So I'm going to square bracket and I'm going to say set P color to red. And then I'm going to close my bracket because brackets in code are like doors. If you open a door, you have to close the door, or all sorts of things you don't want are going to happen. So ask patches, I'm going to hit enter. And there it is. Now, I also want to tell you that when you teach code, if you jump into teaching code to your kids, there's two things you must do. You must make mistakes. And in my videos that I have on the site, I make mistakes because they need to see what happens when you make a mistake. So here I'm going to make a mistake. I'm going to ask patches to set P color to be purple. Now, you will notice purple is black. We're going to go with it anyway. Here it is. It's going to tell me what's wrong up here. It's like, hey, I've never heard of purple. Purple's never been defined. And I'm like, I wonder what is going on. I can go to my color chart and I can see that purple is actually called violet here. Okay, so I'm going to come back here. Nope, back to my page. I'm going to come back here. I'm going to say ask patches. Set P color to violet. Okay, and then you see the color's right, everything's right, and there it goes. Now, it's only so fun to code one line at a time for a little bit. And so if you go down here to NetLogo code, I'm going to close that command center. Down here in NetLogo code, you will see two pre-created functions. So between the word to and end, that is a function for setup. And if you look, that code will be executed when you touch this setup button. So let's see what happens when I press it. Here it has this. This is actually what a turtle looks, what a turtle is here. And so when you look at this code, this is actually the code for create one turtle. And then it's saying, hey, set the size for 3. Well, let's change that. Let's set it to 7. Now, when I hit setup, it looks the same size. And that is because if I in down here in my NetLogo code, I asked it to make a change, but until I recompile that code, it's not going to think about it. So now I've recompiled my code and I go up to setup and there is a turtle, right? And in a much bigger size. Now, the interesting thing is NetLogo keeps it interesting. Every time I hit setup, it's going to keep doing it. It's going to randomly generate things that we don't tell it. So if I don't give it a specific color, it's just going to change the color each time. So, so down here is to go, right? Is a go function between the words to and end. That is what you're gonna have, what's gonna happen when I hit go. So nothing's in there right now. Now, in a go function, and this happens because we learn it, right? And I think it's very important we tell our students, we don't just know this stuff, we don't just memorize it, we can look these things up, right? And so I've given you some resources to start looking it up, and you can also Google these things. And so video games code tend to have this concept of ticks for time, right? So up here is our speed. So this model is going to do whatever we tell it to every tick in this game. It's not a second, but it's like a passing of time. So I'm going to say something here. I'm going to say, okay, ask turtles. I'm going to ask my turtles, I want them to move. I'm going to say FD for forward, 1. Okay, and I'm going to close it. Now, I need to recompile my code. And now I'm going to hit go, and I'm going to see what happens. And this helps you understand something too, because coding in video games and in all sorts of things, you can have things on top of each other. So when I hit go, we're really going to see how many of these we had out there. Now you can also see how I can affect the speed of ticks by this scroller up here. So very quickly, we have color, we have action, we have stuff to manipulate. And I feel like that does really, really well for our kids, right? Especially my kids for ADHD, they love it if something immediately happens. You can immediately see if it's working. And there's just this great joy. So let's do this. If I want to come back, I'm going to stop it. I'm going to hit setup again. Okay. I'm also going to ask these turtles. Now, I can ask for several things at a time. I'm going to ask these turtles, well, I'm going to do it up here. I'm going to say set shape. Let's see. There's my shape chart. I could, in the spirit of bugs, in the spirit of ants, we're going to do a bug. I'm going to set the shape for a bug. Now, this is interesting. You see that it's black there. And when I look here and I'm like, no, but I was told the bug was there. Now, this is because bug is a string. Now, words don't really have much meaning to a computer. So strings, things the computer will take your word for it if you put it in quotes. So if you see, if I put bug in quotes, there it goes. It's the color again. I'm going to recompile my code. And I'm going to hit setup and I'm going to go. And now you see I have one bug of many. Now say you wanted to just clear all. You don't want all this stuff every time. I believe clear all. Nope, that's not it. I will have to look at my cheat sheet because I know I have clear all. So clear all needs a dash in it. So we're going to come back here. And that's exactly how I want you to model it for students. I want you to make mistakes. I want you to reference things. I want you to look at it. Oh, clear all is, oh, okay. It's saying, hey, you can't do that. I can put it, I can't do it in something that's creating a turtle. I have to do it at the beginning of my function. There we go. So here we go. And here we are. So in a matter of 5 minutes, where are all the cheat sheets located? Excellent thing. If you go to ninjapandas.com, we follow to these lesson plans. I have them all under the student view. So if I'm a student and I'm creating, they're in these buttons. They're colors, shapes, and code sheet. Yeah, very good question. My bad. That's no fun to not have that stuff. Now, what I like about NetLogo is that caps don't matter as much. Spacing doesn't matter. Like it's really pretty loosey-goosey, right? Like usually you can't just capitalize or not capitalize things, right? In this language, you can. It's really just sort of gentle. And even when you make a mistake, it's pretty easy to see what's going on. All right, let me make sure. Now, what I want to do is, do you guys have questions on this? Now, on these cheat sheets, you can come in here and you can actually say, okay, I talk about how to make motion, how to use random. So, it also reinforces some of your math concepts and stuff like that. But what I love creating scenes. I like asking my students, okay, I want you, this is what I'm going to do. I'm going to copy a piece of my code here. This is a piece, you can use XY coordinates, and I need to add that to the site. The net logo screen is an XY coordinate system, very much like you teach in math. And it goes from -16 to +16, -16 to +16. And you can set things onto your thing like that. So I'm going to come in here and I'm going to ask Patches. I'm going to add another line of code. Oh. Let's see what's going on. I'm going to ask my Patches, recompile my code. Expected a command. Ask Patches. Closing bracket. All right, so asking my Patches. Do you see what I'm doing? I have an end. Hold on, let me go back to my cheat sheet. Okay. I totally did it this way. All right. Come back in here. Now, if you were ever teaching code and 30 people are staring at you and you can't get it to work, I offer extra credit for the kid that can get it to work. And that actually will fix a problem brilliantly. So here I have my bug, I have my ground, and I have my sky. What I did was I asked Patches with a P coordinate of under -5 to set to this color. And so you begin to see almost naturally how it works. And yes, I'm going to go over clear all again. So clear all has to have a hyphen in it, clear all, and you would add it into a setup or a go. Well, you wouldn't want to add it into a go because it would clear everything, every tick, and nothing would ever show. But clear all, the reason it didn't work initially is because I was trying to put it inside my create turtle. That's not where you need to create things. That's all about creating a turtle. So I do it right inside the setup function, clear-all. And when I got the error, I'm going to recreate the error. I'm going to show it to you. I'm going to recreate the error. That's a very good question. Recompile my code. So it says line 4. It'll always tell you the line. Line 4. You can't use clear all in a turtle context because clear all is observer only. Like it can't be inside a turtle. And so I'm like, huh. And so if it's observer only, it can't be inside. I can't talk about it inside a turtle. So when I come back here, now that may not have fixed it, but I'm going to try. And it really works if you try something and then it still doesn't work and you try again. But you can always ask your students too, because no one can find an error better than a student. Let's try this again. I thought I took it out. See, didn't take it out. There we go. So I'm going to recompile my code and hit go. Now, the other thing I like is that it's easy to change directions. I like that it reinforces these concepts that we already do. So like if I go into my cheat sheet here, I come down here and I can talk about how to change the direction of your object. Okay, so you think of your object in terms of 0 to 360 degrees. So if you want them all to go just to the right, I would set it at 90. So if you're ever working with degrees, you can kind of come in here and have your turtles do this. So here I asked my turtle to go forward. I'm gonna, oh, not clear all. I'm going to set direction for 90. And direction is black. So heading. I used the wrong word. And you know, it's interesting. Every language has its own things. And so we don't memorize all this. We just look things up. Now I could get onto Google and say, Google, in NetLogo, how do I change the direction of a turtle? And it'll tell me. Okay, so I'm gonna go here. I'm gonna recompile my code. I'm gonna hit setup. I'm gonna hit go. And you see how we turn. And you see for a second, let's try that again. You see for a second how he started to go forward and then he turned. It's here, watch, we'll slow him down. I'm gonna slow him down even more. You see for a second, he did that. And it's because the order I did. Code goes in an order, it's top down. So if you sometimes doing things in the wrong direction, if you add an object over another object, it'll cover it, right? And so those are just the little things that you learn by exploring. Now, as you teach this to your students, know that you have to make mistakes, right? Because that's how you see how to fix them. You have to show them how you find this information. And because it's, you know, code is all about failure. And this is what I tell my students, right? Failure is our best friend. If you don't make mistakes when you start coding, you're never going to learn as much as somebody who makes more mistakes. So coding is about failure. And in reality, it doesn't matter. This could be your job. You could be the best coder in the world, and you're still going to code until you hit an error and then figure out that error and then do it. So these are some tips for your students. Always do it one thing at a time. If you want a red sky and brown ground and 5 bugs, you do it one thing at a time. I often have my students write it down, what they want to do, so they get to break it down into lines and figure out how to piece it into pieces. All right. Do you guys have other questions? Ask me in the comments since I can't seem to unmute you. I would love to know if there's anything else you want. I am going to show you this. All this is on the Ninja Pandas site. And so you have your lesson plans. You have, if you're a student, there's a bunch of videos. I tried to make it not look like much, but also give them everything they needed in one place. Because as a remote teacher, I know that trying to get students from one site to another site and back and forth can make you dizzy. All right, so I found all those resources by going up there. Here's your code, your worksheets, and the worksheets may have to be changed for your age group, right? I basically want them to take screenshots. I want them to talk about things. They're not complex, but sometimes you just need some sort of structure to have them focus and get it through. What other questions do you guys have? Well, in that case. Now, when I come back here, while I'm waiting for questions, you will notice that everything is gone. That is, it's a very Zen approach to coding, but then again, you don't really want to be taking all these code files, opening them, checking them. It becomes a pain. So in the worksheets, when I ask them to show me what they've done, I have them screenshot, I have them copy and paste their code, and I have them screenshot stuff. And that way, we're not overly attached. It's not your masterpiece. You could save stuff that way. Let's see. So I taught you a little bit about coordinates, about color, about shapes. I have 5 minutes left, says my moderator. So what other, do you guys have any other questions or comments? Do you feel like you can do this even with younger kids? I'd love feedback. I haven't done it with like super young kids outside my daughter. Yeah, good. I like that you, and there is so much to learn. I mean, the textbook on NetLogo is giant, but it has really friendly, let me show you. NetLogo, would API be? You can actually, I'm going to call it, let's see if documentation is better. I feel like that might be connecting. There is a documentation PDF, but I found that for my students, it's a lot of reading. It's a lot more reading than they really wanted to do, right? So I tended to come in here and find what I wanted. I actually found that Googling things works a little bit better. So I can say in NetLogo, how do I move an object? Right? And you'll actually find some coding sites that'll help you with this, but you'll also see move to, right? So this is actually like, it's going to move to another object. Like if I wanted my little turtle to go to a big turtle, I could move to another thing. It's a lot of coding with relationships that I like. All right, I have 3 minutes left. Any other comments? Do you guys see you being able to use this from middle school? You guys, do you guys think you can throw it in as your sub plans? If a student wanted to save their work, this is what I have them do. I have them copy their code and put it in a Google Doc, right? So it's not gonna, the way this is all set up, it's really sort of a hack, right? So it is not set up to save their work in this environment. But what I would do is, I think one of the best skills all of our students can have, but still very few of them have in high school, is the ability to copy and paste and a screenshot. And so I would even, I would have them copy and paste it and put it in a Google Doc. Right now, this part's pretty, oh, I don't want to share it. This part's interesting. I wouldn't put it into a Word document. If you put it into Word, it's going to give it all sorts of other formatting. Code likes to be in like an undecorated text file. Google Docs don't seem to decorate it. They kind of reserve judgment and stuff until you actually export it. So you could copy and paste this right back in. So you could say, oh, okay. So if they were here and they lost everything, right, you could come in here, you can copy it and paste it back in. And I did have students that were working on really big projects, like where they really did intricate drawings and intricate interactive drawings. And when they did that, they would save their code and in a file. Yeah, excellent question. Any other questions you guys have for me? It was a pleasure to talk to you. You guys are amazing. You're on the front lines doing amazing stuff. Thank you for letting me enlist you in my MacGyver style of how to approach computer science. But really, you know, the wave of the future, lots of people are going to be able to code. Machines are going to be able to code. We need students who can think, who can explore and create. And I feel like that's our students. So thank you very much. Have a wonderful, wonderful rest of the conference. And it was awesome working with you guys. Thank you so much. Thank you. Aw. Bye, guys. Awesome having you. Thank you so much. You got over your fear of code? That made my day. That made my day. All it is just it's a conversation with a computer. Bye, guys. You did amazing. Maybe next time, someday, we'll see each other in person. Thanks, guys. Bye. That was awesome. I loved having you guys. All right. Thank you, Steam. Bye, everybody. See you later.